Hi everyone, thank you for joining. In this video we're going to solve some interesting integer equation where we have x and y are integers, q is a prime number and m here is an integer as well. So we have x is an integer, m is an integer, y is an integer. On top of it we have q, which is a prime number. And the question is that we want to prove that indeed there are no xy such that x and y are elements of positive integers, which solves this equality. We want to prove that, right? Okay, so if you like to pause the video here as usual and try it yourself first, then we will go over it together. So where do we start from? Well, one thing to notice is that left-hand side of the equation x into x plus 1, well, since x is a positive integer, these are relative primes, yeah? Now, if you haven't heard of relative primes before, it's something like 8 and 11, for example, right? Greatest common divisor is 1. 8 is not a prime number, but relative to 11, it is a prime number because the only common divisor of 8 and 11 is 1, right? So x and x plus 1 are relative primes, okay? Now, looking at this equation here, given equation here, right, we must have that q to the power of 2m dividing x, and we must also have q to the power of the 2m dividing x plus 1, right? I'm simply comparing left-hand side with the right-hand side, right? Okay, so it must divide that. Now we're going to make use of this relation here. I'm going to write it as if q to the power of 2m divides x minus 1, that means x plus 1, that means x plus 1 must be greater than or equal to q to the 2m, right? Now let's put this in a box because we're going to use it a bit later, right? Okay, now next thing, let's play around with this given equation, so we can write it as q to the 2m y into y plus 1 minus x times x plus 1 is equal to 0, right? Just rearranging the given equation. Let's expand it, so q to the power of 2m y squared plus y minus x squared minus x is equal to 0. Let's multiply everything by 4, so we have q 2m 4y squared plus 4y minus 4x squared minus 4 is equal to 0. Notice that this is quite similar to 2y plus 1 squared, and this is similar to 2x plus 1 squared. So let's go ahead and write it. So we can write it as q to the power of 2m, 2y plus 1 squared. Now that will give us first two terms, but it will also give us an extra plus q to the 2m. So we do minus q to the 2m here. And then we say minus 2x plus 1 squared. That will give us 4x squared minus 4x plus 1. But then you're multiplying by a minus, so it will be minus 1, therefore we want to add plus 1 is equal to 0. So we haven't changed anything. And the motivation behind this is, if you look at it, we also have some kind of difference of squares, right? So we have q to the power of 2m, 2y plus 1 squared minus 2x plus 1 squared is equal to q to the power of 2m minus 1, right? Okay, now using the difference of squares, q to the power of m, 2y plus 1, let me use square brackets for that. That would be a minus 2x plus 1 times q to the power of m, 2y plus 1 plus 2x plus 1, right? Okay, is equal to, if you haven't quite followed it, all I'm doing is that we have a squared minus b squared is equal to a minus b times a plus b, right? Now let's analyze this situation, because we know q is a prime number. So on the right hand side, what we've got here is that we have a positive term, and this term here is also certainly positive, and we're multiplying it by another term, so this term must be positive as well. That means if q to the 2m minus 1 is equal to a product of a and b, that means it must be greater than the partial, the parts of this product. For example, we can take 2x plus 1. That means q to the 2m minus 1 must be greater than 2x plus 1, right? So that implies q to the 2m is greater than 2 into x plus 1 if you take minus 1 on the other side, right? Okay, now this is the second inequality. So let's compare this with our first inequality, which was x plus 1 is greater than or equal to q to the power of 2m. So let me write that. So we have x plus 1 is greater than or equal to q to the power of 2m. But what we have at the same time, we are saying 2 times that must be less than or equal to q to the power of 2m. Well, since x is a real number, it's a positive integer, so this is impossible. In other words, this is a contradiction, yeah? Okay? In other words, we've proved that if q is prime and m is a positive integer, then this equation has no integer solutions for x, y, right? Okay? Well, I hope you enjoyed it. I hope you found it interesting and challenging. Thank you so much for joining, and I look forward to seeing you in my future videos. Thank you.